This episode is sponsored by my online training portal, which is designed by me to help you become a building forensics badass. You can get free access right now at buildingperformanceworkshop.com. Enjoy. Welcome to the Building Performance Podcast from Green Dream Group in Chicago. I'm Corbett Lunsford, and today we're talking about trends in high-performance building and retrofits from the spray foam angle with Robert Lepage, who is the owner of XL Shell Systems, LLC in Albuquerque. Robert, thank you very much for talking with us today.
Oh, happy to be here. Thank you for having me.
So you've been in the spray foam business since 1969. Can you tell us about, you had one of the first spray foam rigs that you were working with a guy who bought a franchise. What was that like?
It was scary because, spray foam is somewhat technical, and it takes a little bit of training to get started. And we got a van that was all outfitted with the spray rig, and it also had bulk tanks in the inside. There were small bulk tanks, but they were in there, and that's not a system that's normally used with a dry air system. So we had to learn all about that, and they sent a guy to help us learn how to spray, and he spent really 2 days with us. It was pretty incredible. There was no way we were going to learn everything in 2 days, but there we were, and he showed us enough, I guess, to make us dangerous, and we took it on from there. And
so,
fortunately, we didn't cause any major catastrophes, but we sure did have quite a learning curve.
Awesome. That was my next question. I'm glad to hear it. Now, of course, there's a fair amount of building science that gets kind of burned into people's minds when they become insulators, hopefully. I would imagine that he didn't get a chance to talk much about that in addition to the how to apply this stuff without hurting yourself or hurting your client.
Right. And really, at the time, we weren't doing roofing, so to speak. I think the roofing applications were probably in their infancy at that point. So we were doing things like, spraying basement walls. We were spraying swimming pool panels because on insulated pools, that was one of the big problems in keeping the water warm was if you could get an insulated panel, you were miles ahead of everybody else. So we'd spray the backside of swimming pool panels and just all kinds of little odds and ends, water tanks and things of that nature. So I guess as far as the insulation part was concerned, we did do a fair amount of spraying in stud bays on new construction. So that seemed to be something that people could consider to be important even back then because they understood the insulating quality of spray foam at that point.
Interesting. Has the chemistry of spray foam, like the way that it looks and feels and the way that it applies, has it changed significantly over the last several decades?
Essentially, I think the components are roughly the same. I mean, they have tweaked it somewhat over the years. Obviously, we've had to change the blowing agent because of the Montreal Protocol and to go to a non-CFC blowing agent, and that's been done. And so, we've gone through that evolution, but we haven't really. I don't think they really changed the basic chemistry of the A and B component. And just as a little insight, all of the flexible foams, for instance, that we have in our cars. I mean, we're all familiar with the flexible foam surfaces in our cars. We sit on, it's in our dashboard, armrests and whatever. I mean, all of that is polyurethane foam also. And I mean, they've been doing what they call crash pad, work with polyurethane for years and years and years, and I don't think that's really changed much either.
Interesting. So can you just briefly give the listeners, in case they haven't been through a class that's about the mechanics of spray foam, kind of how spray foam works? What is the A and the B components, and what's the blowing agent and all that stuff?
Well, I won't really get into the chemistry too much because I'm not a chemist, but I mean, I have learned a little bit over the years. But basically, if you want to think of it this way, the A component of the mix is what you might call the hardener, and the B side is the resin side, which has the blowing agent and the other components that it needs to be able to form itself into a plastic. And what the blowing agent really does is, when the two components come together and they combine and they do their chemical reaction, they create heat, which makes the blowing agent boil. and it forms all these tiny little bubbles, millions and millions of little bubbles per cubic inch, and that's what gives it such an incredible insulating ability. And really, the chemistry and the refinement in the chemistry comes from being able to control the rise and the hardness and the density and the what they call the dimensional stability of the material. And all those things come together and form the hard surface or the durable surface and allow it to expand and contract without coming apart and to last for, we know we've got roofs out there that are 20 and 30 years old and they still perform great. So it's a very long-lasting material, and that's the reason is because they got the chemistry right. So
interesting. As far as chemistry goes, I mean, other insulation, you can just take a big pile of blown stuff and you just put it through a blower and it just sprays all over the place. You can put bats up, and you can do that with just gloves. This is a much more sophisticated system where there's actual chemistry involved. And like you said, you're not a chemist, so it's like, I don't want to get my hands into that mess.
Right.
But there are so many different factors that you just listed with the dimensional stability and the hardness and all that stuff, and the fact that the heat needs to be perfect to make it boil, but not too hot so where it starts, creating heat problems. How often do you see this stuff done wrong in the field? Because, of course, the installer is the one who really is the one who needs to be the expert.
Right. I mean, we see more problems because, with the company, our current LLC, the XL LLC, we do, or we specialize in foam roof repairs. That's pretty much all we do. We do recoats, repairs, and maintenance work for people that have foam roofs. And, we have over 800 clients that have a maintenance program with us that we go back and look at their roofs every year as a preventive maintenance aspect. But, what we see more often than not with foam roofs isn't so much the fact that the applicator didn't have the heat right. It's more of really two things. One is they don't have enough knowledge to be able to understand how to keep the equipment pumping the material on ratio. In other words, you have to have a 50-50 mix of the A and the B component. And, those things are meant to be mixed that way because obviously that's the way the chemistry is set up. So if you allow one to be, say, 70% and the other one to be 30% of the mix, then you're going to have a problem because the result is going to give you a material that doesn't meet the specifications of what the material is supposed to be. So right at the beginning, and the foam can look okay at first, but over time, as it starts to do its expansion and contraction, because it doesn't have the properties that it's supposed to have, it starts to come apart and it could form bubbles and do all kinds of stuff that, you wouldn't expect. And that's probably the biggest, error that we see in foam applicators that are out there. And I think that a lot of that comes from people that see spray foam and they think, oh, this is a good idea. I think I'll do this. I'm going to buy a spray rig and I'm going to go out there and I'm just going to foam everything. It's going to be great. But then, especially when you're doing a roof, you kind of have to know how to be a roofer. And you have to understand roofing details, and you have to understand how spray foam can work with the roofing details that are there. Because believe me, no architect really, there are architects out there that design and draw a roof system to be able to work with spray foam, but generally the roofs are designed to work with the other conventional roof systems like single ply and modified and tar and gravel. So when you get to a roof project, you have to understand how these details are supposed to be done.
Interesting.
Those are the two things I think that we see that are the biggest contributors to something that would go wrong. From people that are inexperienced.
Yeah. So let's talk, because there's always, I feel like spray foam is probably one of the most controversial products out there in our industry. Everybody gets really nervous about it one year, and then the next year everybody says, oh, no, it's totally fine. They've figured it out. And then the next year everybody's nervous again. Why, in the first place, aside from the fact that it's much more complicated than any of the other components that we're using,
right,
why are people freaked out so often and then repeatedly? And are the problems actually getting solved, or are they all the problems that come up based in installer error?
Well, when you have an installation in a high-profile application, say on a university or a government building, and the job just happens to go bad for whatever reason, say, and it's generally going to be something that has to do with some type of inexperienced applicator or inexperienced foreman that directing his applicator to do something wrong. That can just, I mean, I've seen video of local news on local news coverage where they're talking about spray foam, and it's not good. They're saying very negative things, and a lot of times they're saying things that are incorrect, but it just gets a lot of press that way. And because we have such a small percentage of the re-roofing market, I think it's within 10% of the re-roofing market, any little bit of bad press like that kind of hurts us. I mean, even in Albuquerque, I go visit architects, and I'm still hearing about the bad job that they saw 15 years ago. I mean, these things stick with people. And again, when you have a small slice of the pie, every little negative, turns into a loss of business because people just don't trust it. But then again, on the other side of that coin is there's a very huge amount of successful projects out there that nobody really ever talks about because foam roofs can be put on and they can last for years and years and years without any problems at all. And so it tends to be hot or cold. It's either you've got the project that didn't go right and everybody's talking about it, or the other projects that did get put on right and nobody ever talks about those because there's nothing to talk about. Nothing's going wrong. So
when you're installing with XL, is this a closed cell or open cell product that you're using? How do you kind of differentiate between those two?
Well, we only use closed cell. We don't do any of the open cell. And the reason that we haven't really ventured into the open cell market at all is because I just feel that when you have a material that you're putting on a surface as insulation and it's permeable. In other words, it'll allow water to enter into it and stay there. And I'm kind of getting into a touchy area because there's plenty
another one of those.
Because there's enough people out there that have seen closed cell spray foam that has water saturated in it, but that kind of relates back to putting in an application improperly or off ratio, as I had mentioned earlier. But as a natural physical property of the material, the way it works is closed cell foam can be a vapor barrier, although it does allow vapor transmission at certain thicknesses. But open cell foam is just permeable by its nature. Mm-hmm. It's going to allow water to enter into it. The bubbles in there they're not necessarily closed. They can be open and probably are most of the time. So water gets in there and it stays there. And I just have a real problem with building material that is able to take on water and hold water. And if it's inside of a cavity or in an attic situation where nobody would see it for a while, it just leads to all kinds of other problems in construction.
So to clarify for the listeners, the open cell that we're talking about is half pound is generally what it's called, and then the closed cell is 2 pound. But Robert, I've noticed over the last couple of years, people have been coming out with new mixes that will have, for example, there's a slow rise injection foam that I've seen used in brick homes. Right. Where they'll put it into the kind of area between the plaster and the brick. And that has the R value of a closed cell foam, but the permeability of an open cell foam. So how does all of the new mixes that are coming out, how do we start to categorize those and actually try to use those in the correct applications?
Well, I would always go with something that has a good history of performance first. So, the closed cell roofing foams, which are about 2.5 pound density to 3 pound density, those are well proven in the industry, and architects and designers specify those all the time, and that's pretty much a proven application and a proven performance product. Now, when you start getting into open cell foam, which has been around, granted, 10, 15 years or so, or possibly longer, I don't know the exact date when that really came on the market, but it has a little bit more history of causing some problems with, as I said, being able to retain moisture And in the recent past, they've had some problem with mixes that weren't done properly, and the off-gassing caused problems with people that were living in the house and all this and that. I'm sure that everyone's heard of that.
Can you actually, since you mentioned that, I've heard people say that it doesn't off-gas, that they have a brand of spray foam that does not off-gas. And I have a really hard time believing that that's true. Doesn't there have to be some kind of a stay out of the house for this long, whether it's 24 hours or 48 hours or whatever?
Generally, if you're doing foam and you're mixing it properly, and it's all all of the chemicals are combined into the finished product, you can generally, according to the manufacturer's guidelines, you can generally go back into the area within in about 24 hours.
Okay, so great.
And sometimes sooner, but I mean, manufacturers tend to be pretty conservative, so I think they use 24 hours as a general time frame.
Mm-hmm.
So. And again, it has a lot to do with the fact that is the material mixed properly. If it's not mixed properly and you have loose, unmixed, or unprocessed chemicals in the area where you put the product, then obviously whether it's off-gassing or not off-gassing, I mean something just is not right. And whether you get off-gassing that hurts people or causes problems that way. I mean, just having things that aren't mixed properly, I mean, it's just kind of like trying to put up a wood frame house with rotten lumber.
Mm-hmm.
I mean, eventually it's going to cause a problem. So
it sounds like the main issue is quality control across the board with this. There is I'm aware that there's a certification from the Spray Polyurethane Foam Alliance that involves quality control and going out and kind of assuring that the core samples are good and all that stuff. Are you seeing that that's taking off? Are people actually asking for that? Are the spray foam installers actually pursuing that certification?
Yeah, they're doing it more now, and they tried this, years ago to do a certification program, but it was either the industry wasn't ready, or the association wasn't ready, or whatever. It just didn't seem to take off back then. I remember they tried it back in the 80s, I believe, and maybe in the early 90s. But this time, we're seeing, at least I am, a lot of response to the certification program, and a lot of people are getting on board because it just makes sense that if you have if you can show that you've done a class and you've done the training to be able to get you the knowledge to get yourself to the next level, obviously. I mean, just look at Angie's List, for instance. I mean, more customers than ever are going to try to find out if you're a legitimate contractor and, what your background is, what your history is, and if you really know what you're doing. This is one more thing that adds to that list of advantages that you can say, yes, I do have the certification. I have been trained. All of my applicators have gone to school, and it really makes a huge difference. And there are even architects and engineering firms now that say that they won't put a spray foam applicator or hire a spray foam applicator unless he has a certification. So it is catching on now, and eventually I see that everyone is going to be on board with and have a certification because they're going to have it, or otherwise you just won't get any work.
Mm-hmm. So you have, we've talked about new homes and roofs, but existing homes are a big opportunity, and you have a kind of a fix for a problem that you see. First of all, can you kind of define what the problem with spray foam on existing homes is?
Well, I mean, you can either do it on the inside or the outside. If you do, if you add spray foam, closed cell spray foam to the inside in the stud base, for instance, you have to strip off the drywall. You have to clean out the stud bays, and then you have to, do whatever work you have to do in there, and then, apply the spray foam, and then put the drywall back up. That's quite a project for most people, and not everybody doesn't want to do that. It's costly, and it disrupts your entire life. But especially if you're living in the house, obviously. But if it's a side project, that's something else. But what we do is we take spray foam and we apply it to the exterior of, and for the most part we do stucco. We spray foam over the exterior of stucco structures, and we spray it directly to the old stucco after we clean it up and prep it, and then after we spray the foam on, we detail it around all the windows and the doors and the bottom and the top of the walls, and wherever we have to do it to make a good appearance and make all the detail work look acceptable. And then we apply a coat of synthetic stucco over the top of it, and when we're done, the home pretty much looks like it did before we ever put any foam on. In other words, it looks just like the stucco house we started with, except that it has a nice, beautiful, clean,
you basically
shiny.
refinished, the outside of the house. So how many inches are you adding to the outside of the house?
We usually do an average of 1 inch on the exterior. And we've been doing the application for about 15 years now, because I know that's one of the questions I get all the time is, how long does this last? And so we've had wall systems, just as I explained, out about 15 years now around the Santa Fe and the Albuquerque area. And so far, we've had absolutely no problems. It's been a 100% total success, no cracks, no delaminations, nothing coming apart. And the only thing that we can see that might have to be done at some point, and we're thinking it might be on about a 20-year time frame, is you may have to put another coat of synthetic stucco on it at some point. So, but it's very long-lasting, and the fact that it doesn't crack is a huge advantage.
And what's the R value of 1 inch of your foam?
Well, by the written document, it says it's about 6.7 per inch. But we know that you get a better performance of the material when it's applied because of the fact that they don't calculate in the fact that it's totally adhered and the fact that it's seamless. So you get a performance bump in the material after it's applied, and we think that that's around 30%, and that's probably conservative. So we try to say, we use the terminology that it has an effective R value of about R10 per inch.
Okay, so that brings that's a touchy subject for me. Is the effective, when people say effective R value in my neck of the woods, it's because they're trying to convince somebody that 5.5 inches of open cell spray foam is effectively R49, when of course it's R19. So when you use the effective, or you're telling people that that's not a real, that's based on your calculations and assumptions, right?
Well, it's not just my assumptions. It's based on feedback that we get from people that have had our system installed. I mean, we know that because of the performance that they get, and, if you want to calculate the utility bills, I mean, you can see that the performance of, say, 1.5 inches of foam on a roof is far better than you would expect that the 6.7 per inch would translate into. So we know that there's something else going on. And you did say a minute ago that open cell, they're trying to make open cell look like it has the same R value as closed cell, and we've even seen that ourselves. And we both know that open cell foam only has about half of the R factor of closed cell foam. So that's something that we've had to struggle against too, because as far as marketing, people that do open cell foam are trying to market it as if it was has the same properties as closed cell foam, and it just doesn't. So there's a big difference in the in the performance and the specifications of those two materials.
So back to your stucco houses that you're applying this to. These are, just to be perfectly technically clear, are they surface drained stucco exteriors? Meaning there's not a drainage plane behind it? No.
Well, unless it's in the wall, but we don't really get to see that. Or in other words, it's not vented, and there is no, installed drainage mechanism, at the top or the bottom of the wall. I kind of compare that to, what you see because I had a business in Houston for many years, and, we know that almost every cladding system has a drainage system at the bottom. And that's because of the fact that the humidity is so high over there that you have a real problem with, collecting water inside the wall assembly. So you have to let that water out somewhere. So as a roofing contractor, you have to be very aware that, we have to be careful not to cut off that drainage system in the wall assembly. So, but here in Albuquerque, where we have such a low humidity for most of the year, we don't have those same kinds of problems. So generally, stucco exteriors are not designed. Although they are trying to change that. There are some codes that are coming on board now, and that have already been instituted, where they're saying that they want a drainage mechanism installed at the bottom of a stucco wall. But as far as the older houses are concerned, they just don't have that.
Yeah. Interesting. So what are you excited about in the next 5-10 years as far as spray foam and just insulation in general?
Well, I just see, because of the fact that spray foam has all of the properties and the specifications that make it an excellent insulation material, the fact that it's fully adhered, the fact that it's seamless, and it has a structural nature to it, which helps to strengthen the surface that you're spraying it to. I see it being used more and more in new construction, and we hope that the system that we're doing on the exterior, that we'll be able to help train more people to be able to do that system, because after a 15-year, if you want to call it a test run, with no problems, I mean, it's obviously a system that really does work, and it's really a solution for existing homes. And I think the more that it gets out there, the more we'll learn how to modify that application to be used in other applications, like houses with siding, houses with brick.
Awesome. Robert, thank you so much for talking with us today.
Oh, you're welcome.
Robert Lepage is the owner of XL Shell Systems, LLC in Albuquerque, New Mexico. You've been listening to the Building Performance Podcast from Green Dream Group in Chicago. I'm Corbett Lunsford. Tune in next time.